Chapter 13, review test. It says, number 1 says the dot plot shows the number of chin-ups done by a gym class. So if we look at that dot plot, we're going to be able to answer A through E using that information. So it says, for numbers 1A through 1E, choose yes or no to indicate whether the statement is true. There are 2 peaks. A peak is the highest point. The highest point of the dot plots. And if we look here, it says that 5 and 11 both had 3 people that did those number of chin-ups, which means both of those are the highest point. So that would make 2 peaks. So that would be yes. There are no clusters. Clusters are grouping of data. So 3 to 5, there's a cluster here. These all 3 have number or have data above them, and there's no gaps in between. And same thing here from 9 to 11, which would make this one false. So no, because there are clusters. There's a gap between 6 and 8. If we look here at 6 all the way to 8, there's no data above those numbers, which means that is considered a gap. So yes, there's a gap from 6 to 8. The most chin-ups anyone did was 15. There's no more data farther off this dot plot than 15. So that would be a yes, because that is the most anyone did. One person did 15. The modes are 3, 4, and 9. That would not be true because the mode is the most often. So 5 and 11 would be our modes, so it is not 3, 4, or 9. Number 2, the histogram shows the high temperatures in degrees Fahrenheit of the various cities for one day in March. Select the best word to complete each sentence. The histogram has blank peaks. The histogram blank symmetry. There's one point here that is the highest. Nowhere else on the histogram does it hit that point. So there's only one peak. The histogram does or does not have symmetry. If I divide this down the middle, this side here looks the same as this side. So it does have symmetry. So it has symmetry. Looking on to number 3. The data set shows the scores of the players on the winning team of a basketball game. Okay, so here's the scores. And we need to look, the median is blank and the lower quartile is blank. Okay, so we need to figure that out. What is the median? What is the lower quartile? Again, the median, you need to put them in order from least to greatest. Five, 6, 9, 13, 17, 22, what's left? 30, and 47. Okay, find the median. Just start marking off numbers till I get to the middle. Oops. 2, 2, 2, 2. So my median is 6. 6 is that middle number here. Then to find the lower quartile, I take all the numbers that are to the left of 6 and rewrite them. And now I need to find the median again in order to find that lower quartile, which is both 1s. So 1 plus 1 is 2, divided by 2 is still going to be 1. So my median is 6, and my lower quartile is 1. If I needed to find the upper quartile, which I do, I need to do all the numbers to the right of that. So I have 9, 13, 17, 22, 30, and 47. Find the median of that set of numbers, which is 17 and 22. 9, 39. 39, you got to divide that by 2. 1, 9. 9 would be 18. 19.5. Number 4. Whoa. There we go. Number 4, the data set shows the number of desks in 12 different classrooms. That shows that right here. Find the values of the points on the box plot. So we need to find these values. So if I need to just use this information and I can solve it. And if I find the median, lower quartile, upper quartile, greatest value, least value. So that's how we read that box plot. So I can already figure out E because I just need to go to the greatest value, which is 24. Then I can find my least value, which is going to be 16. Those are already done. I didn't have to do any work to find those. Now I need to actually do some work and put them in order from least to greatest. So I have 16, 17, 17, 18, 19, 20, 20, 21, 21, 21, 22, and 24. Find the median. 20 plus 20 divided by 2 is going to still be 20. So that means C, this right here is my median. That's going to be 20. Then if I look over here, I got to find the lower quartile. So I need to take 16, 17, 17, which right there is my median, so I include the 20. 18, 19, 20. Find the median. 17 and 18. Mm. 17.5, that is my lower quartile. Now I just need to do my upper quartile. Last one. Upper quartile would be these numbers here. So I have 20, 21, 21, 21, 22, 24. That would be 21. If it's there twice, then I don't need to do the math. It's still going to be 21. Okay, so that's how I found those values. Remember, this right here, that's your least value, greatest value, median, upper quartile, lower quartile. Number 5, the box plot shows the number of boxes sold at an office supply store each day for a week. For numbers A through D, select true or false for each statement. The median is 18. This is my median. That does not say that it's 18, so that is going to be false. The range is 15. I need to take this number minus this number, which happens to be 21 minus 6, which gives me 15, so that would be true. The interquartile range is 9. To find the interquartile range, I take my upper quartile minus my lower quartile. So I need to take 18 minus 9, which is going to be 9. So that is true. And the upper quartile is 18. We just solved that already because that's what that far side of the box means, is the upper quartile. So that is also true. The data set shows the number of glasses of water Dahlia drinks each day for a week. So what is the mean number of glasses of water Dahlia drinks each day? So we just need to add those up. We take 10 plus 9 plus 9 plus 8 plus 7, 7 and 6. Add those all up, we're going to get 56. Divide it by 7 because it says for a week. There's 7 days in a week. I didn't even have to count the number of values I have. Take that divided by 7. That's going to give me 8. So what is the mean number of glasses of water Dahlia drinks each day? That is 8 glasses. Part B, I'm not going to scroll down, I'm just going to write and talk here. So it says, what is the mean absolute deviation of the number of glasses of water Dahlia drinks each day? Round your answer to the nearest tenth. Use words and numbers to support your answer. Okay, so if we do the mean absolute deviation, that's the distance away from the mean. If my mean is 8, I'm going to take all these distances and find the difference between that and 8. So 6 is 2 away, so I'm going to take 2 plus 7 is 1, 9 is 1, 9 is 1, 8 is 0, 7 is 1, and 10 is 2. Take all of those, add them up, and divide by 7 again, which is going to give me, when I add those up, 2, 3, 4, 5, 2, 3, 4, 5, 6, 7, 8, 8 over 7. Which when you divide that out, it's going to give you the decimal 1.14. But it says to round our answer to the nearest tenth. 1.14 is going to round up, no, down, sorry, 4 rounds down to 1.1. So 1.1 glasses is the mean absolute deviation. Now it says to use your words and the numbers to describe that. So what you should write is something along the lines of the mean is 8 glasses and the distance of data values from 8 are 2, 1, 1, 0, 1, 1, and 2. The mean of the distances is, and then you can show this work that we just did here, and then you explain why you got from this number to this number, which is that you had to round to the nearest tenth. So when you round to the nearest tenth, 4 needs to round down, which means it leaves you with 1 and 1/10. Number 7, the numbers of emails Megan received each hour are 9, 10, 9, 8, 7, and 2. The mean of the data values is 7.5. The median is 8.5. Which measure of center better describes the data, the mean or the median? Use numbers and words to support your answer. Okay, so looking at this data set, okay, looking at this data set, and this is the median, and I mean that's the mean and that's the median. So the mean is 7.5, the median is 8.5. That means that the median is the better choice because the mean is less than 4 of the 6 data values. The median is close in value to most of the data values. Okay, so it's just saying that the median is closer because it is closer to all of these numbers than 7.5. 7.5 is really only close to 7. 8.5 is close to 8 and 9, which is the majority of those. Number 8, the number of miles Madeline drove between stops was 182, 180, 181, 184, 228, and 185. Which measure of center best describes the data? Mean, median, mode, Which one would that be? So if we look at that, put these in order. There is no mode, first of all. I'm thinking that the mean is not going to be that great because I have a really big outlier. It is way above the rest of these. But if I find the median, it is going to be 183, which is right in the middle of that set, and it's close to 1, 2, 3, 4, 5 out of the 6 data values. So the median would be our better choice there. Number 9. The histogram shows the weekly earnings of part-time workers. What intervals represent the most common weekly earnings? So the most common, that means the mode, so don't overthink it. The two that occur, the most. Okay? So that would be 321 to 330. And 341 to 350. Now you might be thinking, well, Mrs. Nicely, but these two both go up to the 7. But that's not the most, okay? The most go on up to that 8. Jordan surveyed a group of randomly selected smartphone users and asked them how many applications they have downloaded onto their phones. The dot plot shows the results of Jordan's survey. Select the statements that describe patterns in the data. Mark all that apply. Okay, so the modes are 37 and 42. No, 37 and 42 is not. The one that occurs the most would be 41. There is a gap from 38 to 40. Yep, there's no data there, so that one would be true. Select that. There's a cluster from 41 to 44. There are no gaps between there. So yes, that is also true. There's a cluster from 35 to 36. No, you could say that there's a cluster from 36 to 37, but there is no data above 35, so that one is not true. Okay. Number 11. Mrs. G made a histogram of the birth month of the students in her class. Describe the patterns in the histogram by completing the chart. Okay, identify any peaks. There is a peak in May, and there's a peak in August. Identify any increases across the intervals. So January to March, it increases. January to March, this increases all the way up to here. Then from April to May, it increases again. It does not increase from March to April, though. That caps off there. So make sure that you don't put January to May. Okay, so then it goes from April to May. And then caps off, then this declines again, but then it increases from October to November. Anytime that it starts low and goes up, that's our increase. Identify any decreases across the intervals. Decreases. So just kind of the opposite of what we just did here. So from August to October, it continually falls down there, okay? So August to October, and then if we look here from November to December, it decreases too. Make sure when you're looking for increases and decreases, you're starting from the left and going to the right. You can't say, well, it increased from December to November, because that's not how the months work. Number 12, Ian collected data on the number of children in 13 different families. Draw a box plot of the data and use it to find the interquartile range and range. Okay, so if we look at this data, we need to find the least value, which is going to be 0. Put it out there. Our greatest value is 8. And then we need to put things in order. So 0, 0, 2, 3, 4. 1, 2, 3, 4 ones. 1, 2, 3 twos. 3, 3, 4, 8. Okay, find the median. 2 is my median. Now I need to find the upper and lower quartiles. So I have 0, 0, 1, 1, 1, 1. My lower quartile is 1, and I gotta look at my upper quartile. 2, 2, 3, 3, 4, 8. My upper quartile is going to be 3. So my box plot should look something like that. Now I need to find the range, which is going to be 8 minus 0. The range is 8. Interquartile range is my upper quartile here minus my lower quartile. So 3 minus 1, which is 2. Number 13. Galvin wants to move to a country where it rains about 5 inches every month. The data set shows the monthly rainfall in inches for a country. The mean of the data is 5, and the median is 4 and 35 hundredths. The mean is 5, median is 4 and 35 hundredths. After analyzing the data, Gavin says that this country would be a good place to move. Do you agree or disagree with Gavin? Use words and numbers to support your answer. Okay, so I agree. The average rainfall is 5 inches per month, but the median rainfall is 4 and 35 hundredths. So for 50% of the months, the rainfall is less than or equal to 4 and 35 hundredths. The month it rained 14 inches helped the mean to be greater than the median, okay? So he wants to move where it rains about 5 inches every month, but when we come up with that mean, this month helps equal out all these ones that are less. But if we look at the median, the median is still less than, okay? But he wants where it rains about that much every month. So we want to find the mean of it, averaging it all out instead of putting it in order and finding the middle. Number 14. The data set shows the number of books Peyton reads each month. Peyton says she usually reads 4 books per month. Why is Peyton's statement misleading? Okay, so for Peyton here, 4 is the mean. The mean is misleading because of the outlier 11. Because that outlier 11 increases the mean. 5 months, 5 out of her 7 months, she read less than 4 books. Okay, so when we look at this, that was less, that was less, that was less. Here she met her goal, this one was less, here she met her goal, and this one was less. So one time she read a lot, which made that whole mean seem like she could say she read 4 books per month, but she did not. "15. The data set shows the scores of 3 players for a board game. We're going to indicate whether each is true or false. So the mean absolute deviation of player B's score is 0. So let's look at player B. For player B, the mean is 90. For player A. For player B, the mean is 100. And C is 96.7. I went ahead and did those calculations because I think you guys all know how to add up these 3 numbers and divide by 3 now. So now, if we look at the mean absolute deviation, that is going to be 0 for A because they're all 90. None of them deviate at all. For this one, for B, we have to add 10 plus 0 plus 10 divided by 3, which is going to be 20 over 3, which will equal 6 7/10 when you figure that all out. Then for C, we have 0.7 plus 3.3 plus 1.7 over 3, which equals 2 3/10. So the mean absolute deviation of player B's score is 0. That is not true. The mean absolute deviation of players A's score is 0. Yes, that is true. The mean absolute deviation of player B's score is greater than the mean absolute deviation of player C's score. B, that's our mean absolute deviation. C, here it is. So yes, that is true. Okay, that is the end of Chapter 13 review test. I went through that a little bit quickly. So if you have questions, please make sure that you ask your teachers. They will go over anything that you're still not sure of before your actual test.